All right, class. Good afternoon, y'all. All right, so we're on page 164, back to rational functions. So let's find the vertical isototes and state the domain for the following function. All right, so for these, you want to find the zero on the bottom of the fraction. Here, let's grab our graphing software and just graph one of these, so you can see what's going on here. There's this function 6x plus 36 over 3x minus 10. Figure out 6x plus 36. 6x plus 36 divided by 3x minus 10. Okay, there we go. And let's see if I can zoom out here. All right, and then we'll get a snapshot. There we go. All right, so if you look at this thing, there's a vertical asymptote somewhere along in here, right? That means the function never crosses this dotted line. If you take the bottom here and set it equal to 0 and solve for x, we would get 3x equals 10. So x is 10 thirds, which is what, 3 1/3. So right here at 3 1/3, that is where the vertical asymptote is. So the vertical asymptote is at x equals 3 1/3. The domain for the function is everything except for 3 1/3. All right. So to state the domain, you can either write this, or you could say all real numbers except for 3 1/3, or you could say from -infinity to 3 1/3 union with 3 1/3 to +infinity. Okay, I should move this down. So these are 3 ways of stating the domain. All right, and this is how you would state where the vertical asymptote is. Okay, similarly, this one, you just look for the zeros on the bottom of the fraction, because it's going to tell you where the vertical asymptotes are. See, when the function approaches an asymptote, it either blows up to +infinity or to -infinity. It gets closer and closer to the dotted line, but never touches it. So for this one, if we set the bottom equal to 0, we'd have x squared equals 16, x equals +4. So that's where the vertical asymptotes are at. Vertical asymptotes. So there's 2 of them for this guy. And then the domain is an x not equal +or -4. Or we could say all real numbers except for plus and minus 4. Or we could say negative infinity to a negative 4 union negative 4 to 4 union 4 to infinity. So any of those would work. Any questions? Y'all remember these?
Somewhat. That's how we would show our work. Like
Yeah,
how you broke it down. Okay.
yeah. Basically, you just want to set the bottom equal to 0. That's showing your work. And then this is the actual response.
Okay.
Your final answer. So let's look at a couple more. So for 3 here, you'd just say 5x equals 0. And only if x equals 0. So vertical asymptote is at x equals 0. Domain is x can't be 0. Or all real numbers except for 0 or negative infinity to 0 union 0 to infinity. Notice we have round brackets here because we're not including the endpoint, which is 0 here. So there's number 4, same thing, x squared minus 4x minus 5 equals 0. Only if we can factor this guy here. We need an x and x. Let's see. Minus 5 plus 1. Yeah. We can only have x equals 5 or minus 1. So vertical asymptote at x equals 5 or x equals minus 1. Domain x can't be 5, x can't be negative 1, or all real numbers except for negative 1 and 5, or negative infinity to minus 1 union minus 1 to 5 union 5 to infinity. So write an equation of a rational function that satisfies the following requirements. So number 5, it has a vertical asymptote at x equals negative 3/2. We could have x plus 3/2. There's a function f of x equals. So you notice if you put a negative 3/2 in for x, you get 0 on the bottom of the fraction. For 6 here, the domain x cannot be equal to negative 1/3 or 4. We could say 1 over x plus 1/3 x minus 4. So notice if you plug in a negative 1/3, you get 0 here. If we plugged in a positive 4, you get 0 there. So explain in your own words why you cannot divide by 0. All right, well, let's look at a function called 1 over x. 1 divided by x. Let's zoom in a little bit. Let's get a snapshot. All right, so we get both of these at the same time. And explain in your own words what happens to the output of a rational function when the input approaches a vertical asymptote. So this is 1 over x. All right, so what is 1 over 0? All right, well, as we get closer and closer to 0, right? If you're approaching 0 from the right, this thing goes to a positive infinity. But if we approach 0 from the left, it goes to negative infinity. So is this equal to positive infinity or negative infinity? It's both, and nothing could be further apart than positive infinity and negative infinity. So there's a vertical asymptote here. So this is an example of taking 1 and dividing by 0, but it happens no matter what you divide by 0, you get a vertical asymptote. So yeah, you get this split here where it goes all the way up and all the way down at the same time. So that's what happens when you approach a vertical asymptote. You get both positive and negative infinity. When traveling at a constant speed, d equals rt. D is the distance, r is the rate, and t is the time. Solve for t. All right, well, just divide both sides by r. How long will it take to drive 195 miles if you average 60 miles per hour? Answer in hours and minutes. Okay, well, using our formula, we want to have 195 miles divided by 60 miles per hour. So notice miles go away and we have 1 over hours. That's how we're going to end up with hours is going to be our result here. So trusty calculator, 195 divided by 60 is 3.25 again 25 hours. So this is 3 hours plus 0.25 hours. So what is 0.25 hours in terms of minutes? Get rid of hours, we want minutes. 1 hour is 60 minutes. Hours go away. So 0.25 times 60 is 15 minutes, right? 0.25 would be a quarter of an hour, which is 15 minutes. So this is 3 hours, 15 minutes. All right, according to A, what happens to time if your speed approaches 0? Well, if this goes to 0, then this whole thing goes to infinity. So t goes to infinity as r goes to 0. Might also write that as the limit as r goes to 0 of t is infinity. That's how they would write that in calculus class. Page 165. I suppose it costs C dollars in billions to build X miles of a wall along the US-Mexico border, given by the function C of X. Approximate to the nearest million how much it would cost to build 1,000 miles of shelter wall. So X is miles, right? And C is in billions. So let's look at it. C of 1,000. 0.425 times 1,000 over 1954 minus 1,000. So multiplying by 1,000 means move the decimal to the right 3 times. This is 425. 1954 minus 1,000 would be 954. So 425 divided by 954 equals 0.445492266. So if this is in billions, how many zeros do we need? What's a billion here? It's 100,000. What is that? 100 million? Should we put those? 0. Hundreds, thousands, millions, billions. This is 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 to the 9. So we need to move our decimal 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be 445,492,660 dollars, or approximately 445.5 billion. All right, according to this model, how many miles of wall would it be impossible to build? 1,954 dollars. I mean, miles. Right, because you would get 0 on the bottom of the cost function. All right, the ideal gas law is PV equals nRT, where P is pressure, R is volume, T is temperature, N is the number of moles of gas, and R is a constant, which is 8.314 joules per Kelvin mole. All right, so PV equals N times 8.314 T. Solve for P. So we have nRT divided by V, right? We're just dividing both sides by V here. According to A, what happens when the pressure happens to pressure as volume increases? Well, if the bottom of the fraction goes to infinity, then the whole thing goes to 0, right? All right, what happens to the pressure as volume decreases? If this thing on the bottom goes to 0, then the whole thing goes to infinity. All right. What value for volume of gas can never be attained? Volume can never be 0. Wouldn't make any sense. Okay, this one was 15 parts to it. That's all right. One part at a time then. Charles's law states that when a gas is held under constant pressure, the volume of the gas is directly proportional to the Kelvin temperature. That is V1 over T1 equals V2 over T2. V1 is the initial volume, V2 is the final volume, T1 is the initial temperature, and T2 is the final temperature. Both T1 and T2 must be measured in a temperature unit Kelvin, not degrees Celsius or Fahrenheit. So Kelvin is Celsius plus 273. And Celsius is 5/9 times Fahrenheit minus 32. So 5 liters of a gas have a temperature of 250 Kelvin. So, all right, this would be V1. And this would be our T1. No, it's going to be T2. I should have read the whole thing. If the previous temperature was 300, what was its volume? So V1, T1 are the initial temperatures. V2, T2 are the final ones. So, all right, they have a temperature like that now. But the previous temperature, the initial temperature, was 300 Kelvin. So what was its volume? What was its initial volume? All right, so T1 is 300 Kelvin. T2 is 250 Kelvin. V2 is 5 liters. What is V1? Well, looking at this, we could see that V1 is V2 over T2 times T1. So we just plug these in. 5, 250 times 300. Our handy iPhone calculator here. 5 times 300 divided by 250 is 6 liters. So what this is saying is you have this 5 liters at this temperature. Whenever you heat it up, well, actually let it get colder. So we start off with 6 liters at 300 Kelvin. If you decrease the temperature to 250 Kelvin, the volume shrinks to 5 liters. So make it colder and it gets, the volume decreases. So that's Charles's law. It's interesting. So you can lose a lot of gas just by the temperature change. So 3.1 cubic meters of a gas have a temperature of 15 degrees Celsius. What temperature is required to increase the volume to 3.5 cubic meters? So here, this is our initial volume and our initial temperature. So they're asking what temperature do we need to change this to increase the volume to 3.5 cubic meters. So here we're solving for T2, right? So looking at this thing, we could also flip these, right? We could say T2 over V2 is T1 over V1. So T2 would be T1 V1 times V2. That down here. V2 over T2 equals V1 over T1. All right, so here T2 would be, let's see, T1 is, well, this is Celsius, right? This thing says that it has to be in Kelvin. So Kelvin is Celsius plus 273. Right? So since we know that, let's see, we need to convert T1 here because T1 is 15 degrees Celsius, right? So this would be 15 plus 273, which is 273. 288 Kelvin. All right, so plugging, these are cubic meters. All right, they don't say what the volume has to be measured in. So whatever unit of volume we use, we're using cubic meters here. The last time we used liters. So because we started with liters, that meant we ended in liters. Here we're using cubic meters. So our since both of these are cubic meters, the cubic meters cancel out. Okay, so if we plug these in, T1 is 288 Kelvin. V1 is 3.1 cubic meters. And V2 was 3.5 cubic meters. Notice the cubic meters go away. We're left with Kelvin. So if we plug that into our calculator, 288 times 3.5 divided by 3.1, we get 325.16 Kelvin. Okay, let's see. So 1,300 cubic inches of a gas are at a temperature of 78 degrees Fahrenheit. If the temperature increases to 90 degrees Fahrenheit, what is the new volume? All right, so this is our initial volume. It's our initial temperature. We're going to change the temperature to 90 degrees Fahrenheit. What is the final volume? So we have V1 is 1,300 cubic inches. We don't know what V2 is. T1 is 78 degrees Fahrenheit, but we have to use Kelvin. So let's write these both down. Kelvin is degrees Celsius plus 273. Degrees Celsius is 5/9 degrees Fahrenheit minus 32. So we're going to have to use these. So what we need to do is convert Fahrenheit. We need to convert Fahrenheit to Kelvin. So if this is Kelvin and this is Celsius, what we're going to do is we're going to take this, plug it in right there, right? So Kelvin is going to be 5/9 degrees Fahrenheit minus 32 plus 273. Substituting one into the other. Now we have Kelvin in terms of Fahrenheit. So T1 here is going to be 5/9 times 78 minus 32 plus 273. So let's see what we get here. 78 minus 32 times 5 divided by 9 plus 273, which is 298.56 Kelvin. Temperature 2 here, 90 degrees Fahrenheit. So this would be 5/9, 90 minus 32 plus 273. So 90 minus 32 times 5 divided by 9 plus 273 is 305.22 Kelvin. All right, so should make this a little smaller, huh? So what do we want to find? V2. All right, well, we know V2 over T2 is V1 over T1. So V2 is V1 over T1 times T2. V1 is 1300 inches cubed. T1 is 298.56 Kelvin. And then T2 is 305.22 Kelvin. Kelvins go away. We're left with inches cubed. So let's see what we get. 1300 times 305.22 divided by 298.56 gives us 1,328.99. So this is approximately, because we're rounding, inches cubed. Now D. 7 liters of a gas are at an air temperature of 300 Kelvin. 6 hours later, the volume was measured at 7.2 liters. What is the new temperature? And then convert that to Celsius. All right, so this is our V1, T1. So later, this was our new volume. What's the new temperature? So T2 over V2 is T1 over V1. So T2 is T1 over V1 times a V2. So T1 was 300 Kelvin. V1 is 7 liters. And V2 is 7.2 liters. Liters go away. We have 300 times 7.2. 300 times 7.2 divided by 7. We get 308.57 Kelvin. We want to change this to Celsius. So let's see, here's our Kelvin to Celsius here. So if this is true, then degrees Celsius is Kelvin minus 273. So this would be 308.57 minus 273 degrees Celsius. So if we do this, 308 minus 2, dang it, 308.57 minus 273 is 35.57 degrees Celsius. Any questions?
No. I don't think I do.
All right, that's that homework section. So let's keep going back in time. There we go. Homework, polynomial functions in their graphs. So let's look at these. Okay, we're gonna match this. So let's see if I can see the whole page here. Zoom. All right. Can y'all read that?
Yeah, it's a little small, but I can read it.
All right. Okay, let's see how we can match these up. Let's look at number 1 here. We got this x cubed. This is number 1 times an x minus 3, right? Where is it 0? So where is it going to be crossing the x-axis? If we plug a 3 in, it's going to cross the x-axis. Or if we plug a 0 in, because the x squared here, overall we have an x times an x squared times an x. So this is a third order, right? Right, a third order means we're going to have something like that. See how it would cross 1, 2, 3 times? Okay. So let's look for something that has 3 squiggles or 3 ups and downs that crosses at 3 and 0.
Is it E?
Hmm?
E
Uh,
below B?
maybe. The thing is, let's see. This guy, that x squared, right? What does that tell us? Because basically we're getting the 3 roots are 0, 0, and 3. Notice 0 is showing up twice. All right. So what that means is look at I here. Because that thing shows up twice, it's not just crossing, it touches. So notice we
Oh,
down and an up again, right? But because that thing shows up twice, that tells us that it's touching the x-axis there, not just crossing it. So I think number 1 here would be I. All right. I didn't even get all of them, did I? Yeah, M and N. Okay. Let's check out number 2. So it's a negative 2x. So we're going to have roots at 0. And we have an x plus 2, so negative 2, and then an x minus 2, that'd be a positive 2. All right, so we're going to have 3 roots at 0, minus 2, and 2. So that looks like maybe this one, but let's look and see if there's any others that have the same roots. No, we don't. So that's going to, number 2 is going to be C. Or I'm going to circle these as we do them. So those are taken. All right, number 3, we have a negative 2. We have this x plus 3 squared, then x plus 1 squared. So we're going to get, because of this, we're going to have a root at minus 3, but since it's squared, it happens twice. Over here, we have roots at minus 1, and they happen twice as well. So what this thing is going to do is it's going to touch the x-axis at minus 3 and at minus 1. So if we look at here, this one, M. See how it's just touching at minus 3 and a minus 1? So 3 here would be M. 4, f of x equals x. Y'all know what that looks like. That's just a vertical line. The input is the same as its output. So that's going to be B here. All right, number 5, we have roots at 1, 3, and 5. So it's just going to be crossing at 1, 3, and 5. So let's see. That would be A. See how it crosses at 1, 3, and 5? So it's going to be A. 6, we have roots at 0, minus 3, and positive 3. So that looks like this one, E. Number 7, we have an x squared, 2 and 4. And the x squared, that means we have roots, we're going to have 0 twice because of the x squared, then the 2 and the 4. So it's just going to touch at 0 and cross at 4 and 2. So let's see, that looks like this one. Right, it touches at 0, crosses at 2 and 4. So that's going to be L. All right, number 8, we need to factor this guy, or at least let's pull out this -2. That gives us an x squared minus 8x plus 12. For number 8, all right, we need to factor it. So pulling that out, now let's find the zeros, right? Can we factor this just by eyeballing it? Let's see. 12, 6 and 2, or -6 and -2. That should work, right? Yeah, so our roots here are at 6 and 2. So it's going to be crossing at 6 and 2, which looks like F. Number 9 is already factored. 3x, that gives us a root at 0. And we have -1 and then a +1 twice because that thing's squared there. So this thing is going to cross at -1, cross at 0, and touch at 1. So right here, D, it crosses at -1. No, that ain't it, because it's crossing at 0. No, that's right. It needs to cross at 0. It's just touching at 1. Yeah, so it touches at 1, crosses at 0, crosses at -1. So this one's D. All right, number 10, 9 minus 4x squared. Where's this thing equal to 0? Let's just set it equal to 0 and solve. So we get a 4x squared is 9, or x would be positive -3/2. So it's crossing at positive -3/2, which is this one. 3/2 is 1.5, so it's crossing those two. So this one would be N. Number 11, let's see. We have an x -4 in there, so we have a root at 4, and x -3, and then an x -1 squared, so 1 and 1. So it's touching at 1, crossing at 3, crossing at 4. That'd be this one. Touching at 1, crossing at 3, crossing at 4. So that's J. Number 12, f of x equals -5. All right, that means you're at -5. Right, here's -5. Every single point has a y value of -5. It doesn't have any roots, so we can't use roots to figure it out. So that one's G. 13, this x cubed, that means we have 0, 0, 0, and then a 3. All right, so let's look at what's left. It's one of these two here, right? When you have these things twice, I said it touches, right? Well, what happens when you have it 3 times? It crosses, but look at what this thing does. It goes and the slope becomes 0, and then it goes down. So that's what happens whenever you have the root happens 3 times. Okay, what is it called? An inflection point. So yeah, either it crosses, that's if it shows up once, right? It touches, that's what happens if it shows up twice. And you get an inflection point. See this? So it's like that. That's what happens if the roots show up 3 times. You get an inflection point. Inflection. So what it is the slope here. The slope becomes 0, right? It's decreasing. Let's see. Yeah, the slope becomes, well, the slope becomes 0 here too. How do I explain this? I don't think it's worth it. So you get an inflection point. Notice the slope is 0 and then it continues down. So that's what happens if the roots show up 3 times. So that's why it's going to be H for 13, because that X cubed, all right, the 0 where it crosses at 0, that's how it gets 3 roots out of it. That's what it looks like visually anyways. We know it's going to be H and not K because you have 0 and then 3, right? So here's your 0 and this is your 3. It can't possibly be K because it has K here, goes through 1, touches at 2, crosses at 3. So right here, touches at 1, touches at 3, crosses. I said that wrong. Crosses at 1, crosses at 3, touches at 2. So that one's going to be your K. Fit width. Okay. So, okay, that was the whole section. All right, we'll go back in time. Find some more homework. Keep going. There's some homework. All right, page 149. All right, solve using solve equations by factoring. So this is just factoring, right? We did a whole lot of this. So if we need to factor this guy and find the zeros, we might be able to eyeball this one. So 5 and 3. 5 and 3 give us 15. They add to be 8. So X is equal to -5 or -3. Right? We could write it all out. All right. So X plus 5 equals 0, or X plus 3 equals 0. So X is -5 or X is -3. That would be showing all your work, but really this is enough. If you get that and you write this down, I know what you mean. So over here, let's see, we'd have 4t squared is 25. So t here would be 5 halves with a plus or a minus. If you're showing all your work, you go t squared equals 25 over 4. Square root of t squared equals 25 over 4 square rooted. If only of the absolute value of t equals 5 halves. Only if t equals plus or minus 5 halves. That would be showing all the steps. All right, on the final, just show as much work as you can, as many steps as you can, even if it's simple. Okay, let's see. This one, we need to get everything to one side of the equation. I don't know if I can eyeball this one or not. It's hard when we have an A here. So we had a trick for doing this. What was it? What do we look at? We look at A times C. See if I can remember the PQ trick. What do we need? A times C and B. This would be P times Q, and this would be a P plus Q. Is that right? Do y'all remember this trick?
It was really familiar,
All right, let's see. So
but I'm not sure.
A times C, 6 times negative 15 would be a negative 90. So we're looking for two numbers that multiply to give us negative 90. B here is minus 1. So we want those same two numbers to add to be minus 1. Okay. So thinking of all the possibilities that multiply to give us negative 90, what if we let P be negative 10 and Q be 9? All right. So they multiply to be negative 90. They add to be negative 1. So what we then do, we take the middle thing here and rewrite it using these. We write it as minus 10x plus 9x. Right? That's the trick. So now we look at these and we say, okay, I can factor 2x out. I get a 3x minus 5. So what I want to get is another 3x minus 5. So looking at that, if I factor out a 3, what do you know? I got a 3x minus 5. So since these are both multiplied by a 3x minus 5, I have a 2x plus a 3, both multiplied by 3x minus 5. And now it's factored. Okay. We can check our work, right? We multiply this by this. That's where we get the minus 15. We'd have a 9x minus 10x. That would give us this minus x. And the 2x times the 3x would give us the 6x squared. So this is your trick for factoring stuff that you can't just eyeball it. You do that trick. And that way you can, I forget what they call this method. I call it the PQ trick. Again, you can use any two letters you want. You could use Z and K. Doesn't matter. So number 4 here, let's see, we can factor out a 10. Right? We divide both sides by 10. That goes away. This is still 0. I can factor an x out, x plus 10. So either x is 0 or minus 10. Oh. These. All right, this one, we're gonna have to do our trick here. So A times C, 9 times 4 is 36. So we need two numbers that multiply to be 36. B here is 12. Those two numbers need to add to be 12. So how about 6 and 6?
There's 6 and 6. Well, you can't do 12 times 3, but yeah, that's the only one I can think of.
Yeah, it should work. So we'll rewrite 12t as 6t plus 6t. So here we could factor out a 2t. So we have a 2t plus 3. Here we'll factor out a 3 and get a 2t plus 3 again. So now we have a 2t and a 3, both times 2t plus 3. So these are the same thing here, right? So t would be a negative 3/2. And it shows up twice. right? So let's look at 6 here. 4x squared minus 23x minus 6 equals 0. Set everything equal to 0, right? So our a times c here would be a negative 24. Our b is negative 23. So how about we let p be negative 24 and q be 1. So we can rewrite this as minus 24x plus x minus 6 equals 0. So if we factor the 4 out, we get x, well, 4x out. Sorry about that. We get an x minus 6. And over here, this is just 1 times x minus 6. All right. So these can be tricky, right? Because you don't see something multiplied by an x minus 6, but you always have a 1 times x minus 6. So we have a 4x plus 1 times an x minus 6. So either x is negative 1/4 or 6. All right. So let's get everything in order here. I don't want to deal with these fractions. They suck. So I'm going to just multiply everything by 9. We got a 9x squared minus 8 times 3 would be a 24. 16 equals 0. Let's see. I might be able to do this. All right, 3x. No, minus 4. I think that might work because the minus 4 times a minus 4 gives us a positive 16. We get minus 12x minus 12x, which gives us the minus 24x. The 3x times the 3x gives us 9x squared. So that one I could eyeball. So x is 4/3. All right, this guy over here, I don't like the fractions. Let's multiply everything by 6. That would give us 3x squared minus 5x minus 12 equals 0. Let's do our trick here. A times c would be a negative 36. B is minus 5. So two numbers that multiply to give us 36, but add to give us negative 5. What, 9 and 4? Negative 9 and positive 4, right? 9 times 4 is 36, isn't it?
Yeah.
So we can rewrite this minus 9x plus 4x. So we could factor 3x out, factor 4 out. So we have 3x plus 4 times x minus 3. So either x is negative 4/3 or 3. Okay. This thing, everything has an x in it. So first, let's factor that out. All right, now looking at that, we can factor this quadratic. We need an x and x. Let's see. Well, let's see, 6 and 2, right? Plus 6 and a minus 2. So x is either 0, 2, or -6. This guy, there's 2s and 3s on the bottom. I'm going to multiply everything by a 6. That'll get rid of all the fractions. So 6 over 2 is 3 times 3 is 9. 18x. 6 over 3 is 2 times 4 is 8. Okay, I guess we'll do our trick. A times C is 9 times 8, which is, what is that, 72? Better check. 9 times 8. Yeah, 72. And B here is 18. So numbers that multiply to give us 72, but add to give us 18. Let's see, 72. So we have 2 times 36. That doesn't work.
What about 18?
18. Hold on. Let's see, 72, 3 and 24. If that doesn't work.
It's 18 and 4.
4 times 18. Yeah, they multiply to be 72, but 4 plus 18 is an 8.
Yeah, it isn't. Yeah.
It's not divisible by 5. 6. 6 times 12. So there's our P and our Q. They add up to be 18. So we can rewrite this as 6x plus 12x plus 8. So we can factor out a 3x. So we get a 3x plus 2. Factor out a 4. We get a 3x plus 2. So 3x plus 4 times 3x plus 2 is 0. So x is -4/3 or -2/3. Got a lot of these for us, don't they? All right. Page 150. Here both things have an x and they're both divisible by 4. So let's just pull a 4x out. It gives us a 5x minus 1. So either x is 0 or 1/5. This one, let's multiply everything by 9. So we get 2t squared plus 9t plus 1 plus 9 equals 0. So our A times C here is 18. B is 9. Numbers that multiply to give us 18, but add to give us 9. 6 and 3. Yeah. So we can rewrite this as 6t plus 3t plus 9. Factor out 2t, we get a t plus 3. And over here, we'll factor out a 3 and we get a t plus 3 again. So 2t plus 3 times a t plus 3. So t is -3/2 or -3. All right. Let's see. A times C. 5 times 12 is 60, right? B is -23. So we need, okay, let's see. -20 and -3. Yeah, they multiply to give us a +60, but add to be -23. So we can rewrite this as -20t minus 3t plus 12. We factor out a 5t, we get a t minus 4. Pull out a -3, we get a t minus 4 again. So 5t minus 3 times a t minus 4. So either t is 3/5 or 4. This guy over here, let's get everything to one side. We can definitely factor out x, right? Is 81 divisible by 36? No. Let's just factor out our x here. This is x. 36 x squared minus 81. So we need to factor this. Now this is the difference of two squares here. All right. 36 is 6 squared, right? And 81 is 9 squared. All right. Remember the difference of two squares? So this would be 6x minus 9 times 6x plus 9. Difference of two squares. Anytime you have something minus something, you can write it as difference of two squares. Right? Let's put that in as a step. This is x. This is 6x squared minus 9 squared. All right, so when you have the difference of two squares, remember a squared minus b squared is a plus b times an a minus b. Okay, and you can always do that just because these are pretty numbers, right? If I had a 27 here, then I would just put the square root of 27 here and here, because every number is something squared. So this tells me x is either 0, 9/6, or negative 9/6. Of course, we could reduce those. All right, first things first, put them in standard form. 23, no, negative 4x cubed minus 23x squared plus 6x. Let's get rid of the minus and factor out the x. So if we factor out a negative x, that would give us 4x squared plus 23x minus 6. Multiply both sides by a minus. Boom. So we need to factor this guy on the inside. So let's let a times c, it's going to be a negative 24. B is 23. So we're going to let P be 24 and Q be minus 1. So we can rewrite this guy as 4x squared. This 23x becomes 24x minus x. So if we factor out a 4x, we get an x plus 6. We pull out a minus 1, we get an x plus 6. So we have x, we have a 4x minus 1 times an x plus 6. So x is either 0, 1/4, or minus 6. This guy, let's put everything in reasonable order here. Let's get rid of these minuses. All right, and we'll do our trick here. A times c is negative 10. B is 3. So how about we do 5 and -2. They multiply to be -10, they add to be 3. So we'll rewrite this 3x as 5x minus 2x. So if we factor out an x, we get 2x plus 5. And over here, we'll pull out a -1, 2x plus 5. So we have an x minus 1 times 2x plus 5. So either x is 1 or -5 halves. Figure, we're past the halfway mark, but I figured we'd finish this section and then call it a day. Y'all are cool with that?
Is the final on Wednesday?
Let me look in my notes. Final week is December 6th to December 11th.
Ours was December 8th.
It's Monday, December 6th from 11 a.m. to 1:45 p.m. No, y'all are the afternoon class. Yeah, y'all's is the Wednesday, December the 8th. From 3:30 to 6:15. All right. What is today? Monday? Yeah, Monday. All right, so see for this one, move everything over. We see we can factor out an x. So this will be a 4x minus 1. So either x is 0 or 1/4. Put this guy in the standard form. We can pull a 2 out. Now, this is the difference of two squares. X minus 5 will be x minus 5 times x plus 5. So either x is positive or -5. That's one way to do it. Or we could have, well, they asked us to use the 0-point method. So they asked us to do it this way. We could have done it the other way and just said x squared is 50 over 2 or 25 and then square rooted. So we went with a bunch of fractions here. All right, so let's get rid of the fractions. Let's multiply everything by 6. Because 2 and 3 both divide into 6. So 6 over 2 is 3 times 5 is 15. 6 over 3 is 2. 6 over 3 is 2 times 4, 8. So A times C here. I don't know what 15 times 8 is. 15 times 8, 120, and it's negative. B is -2. So 10 and 12, right? Would be -12 and 10. That should work. So we have 15t squared minus 12t plus 10t minus 8. Factor out a 3t, which is a 5t minus 4. Pull out a 2, 5t minus 4 again. So 3t plus 2 times a 5t minus 4. So t is either -2/3 or +4/5. This guy, look at all these fractions. If we multiply everything by 12, this one won't go away. So how about 24? If we multiply everything by 24, all these fractions will go away because 3, 8, and 12 all divide into 24. So 24 over 3 is 8. 24 over 12 is 2 times 7. And then 24/8 is 3 times 5 is 15. We need to move it over to the other side of the fraction. So our trick says, a lot like the last one, 8 times 15, it's still minus 120. B here is 14 though. So it can't be 12 and 10. What are our choices here? 120 times by 5. Well, let's see. 2 and 60 doesn't work. 120 divided by 3. 3 and 40 doesn't work. We divide it by 4. That doesn't work. Divide it by 5. That won't work. 120 divided by 6. 6 and 20. Getting closer. Well, that would be it, right? Because it's negative 120. So one of these has to be negative, the other one positive. So if we do a negative 6 and a positive 20, that works out. So here's our P and our Q. So we get 8x squared minus 6x plus 20x minus 15. So we can factor a 2x out, we get a 4x minus 3. Factor a 5 out, we get a 4x minus 3 again. So 2x plus 5 times 4x minus 3 is 0. So x is negative 5/2 or 3/4. Page 151. Give it an equation you prefer to solve using the zero factor property. Give an equation you prefer to solve by the quadratic formula. Okay, the zero factor property. How about something that's already factored? X minus 3 times x. That's how I went that one. I can just look at it and write the answer down, right? Now, as far as the quadratic formula, the equation that I would rather use the quadratic formula for, 3x squared minus 9.78x plus 6.92. Right? I wouldn't want to try to factor that. All right, I could just write x is negative b plus or minus the square root b squared minus 4ac all over 2a. Boom. Plug that in the calculator and I got it. So not everything you want to factor. Quadratic formula is very useful. Let's graph this guy. Let's see, A here is negative, right? So it opens downward. The axis of symmetry was at negative b over 2a. Now remember this stuff? So there is no b here, so that's at 0. So boom. Remember, our vertex lies on top of the axis of symmetry. We plug that in. F of 0, in this case, would be 1. So boom. This thing's going to open downward. The y-intercept is at 0, 1. The x-intercepts, if we set this equal to 0, we would have x squared equals 1, right? So the zeros are going to be at positive and -1 is where our zeros are. So +1, -1. We know it goes through there. We know it opens downward. Okay. The domain, all real numbers, it goes forever right and left. The range, oops, it goes all the way down to -infinity, but it makes it up to a +1 with a square bracket because it includes 1 here. Okay. Do another one. Oh. Some word problems, all right. All right, answer the following. A rocket carrying fireworks is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. All right, the height is given by h of t. How long will it take for the rocket to hit 128 feet? So here's our height function. So they want to know how long. We're looking for a time when the height is 128 feet. So we set the height to 128, and now we solve for t. So to do that, we need to put it in standard form. Let's see, 80 minus 128 would be a -48, right? All right, so to solve this, yeah, we can pull out a -16 here. We're going to get a 1 minus, not a 1, sorry. We get t squared minus 4t plus 3. We could divide both sides by a -16, right? This is still 0, goes away. We factor this t -3 and a -1. All right, so we got time 1 or 3 seconds, which makes sense. They're asking when is it at 128 feet? Well, you can see if you plug 0 in for time, you get 80. So we're starting here out 80, and it does this. So here's our 128 feet. Happens at time 1 and time 3. So after how many seconds of it being launched will it hit the lake? Well, this is our height formula. So it hits the lake when the height is 0. So we set it equal to 0, and now we solve for t. Let's see. To do that, we could still factor out this -16. So this was -4, and this will be a -5. Divide everything by that. We factor t, and -5 and +1. So -1 and +5. This one doesn't make sense. Negative time. So it's at 5 seconds. Basically, this thing kept going down here. This would be at a -1. We don't care about that. And you can always graph these. To, graphing always helps. Let's look at another one. Fill in the blank to create an equation that may be solved using the zero factor property. You can put any number in there. What, 7x? because we could factor that, right? Let's see. No, that wouldn't work. Let's see if I wanted to use for -12, two numbers multiply to give me -12. Let's do -6 and a +2. All right, then I would have a -6x plus 2x would be plus a -4x there. All right, explain in your own words how to solve the following equation using the zero factor property. All right, so first thing we do is we put it into standard form. So 12x minus 4x would be 8x. 20 minus 5 would be 15. So now it's standard form. Now I'd eyeball it and see if I can factor it because there is no a here. I would do this. I know I got an x and an x because of the x squared. Now I need two numbers that multiply to give me 15, but add to give me an 8. So I'm thinking 5 and 3. So now I check my work. 15, yeah. X squared, yeah. 5x plus a 3x is an 8x. Boom. Then we set each of these equal to 0 and solve. So x is -5 or -3. All right, so that's that section. So next time we will the next homework section, which is right here. Page 137 is what we're going to do next time.
So, sir, will we have class on that Monday that your other class has its final or no?
No, that finals week is only finals.
Okay.
Yeah. So we have what, just next week, right? And then that's
Yeah.
it.
We have this Wednesday, and then I think that's it. Because next Monday is the 6th, which I think is what you said finals were.
Yep. Yeah, that's right. So one more class.
This is crazy.
Yeah. All right, folks. Y'all have a good rest of your day, and I will see y'all on Wednesday.
See you later, sir.
Have a good day, everybody. Thanks, Professor.
You're gonna have to bring your daughter the last day of school, though.
Yeah, please.
I'll see what I can do.
At least show pictures.
All right.
All right, bye.
Bye.